Geometry is magic. Let me say that again for emphasis because it's important. Geometry is magic. If you don't believe me, then consider the following simple example. Say I wanted to tell you about a triangle. Well, then I don't need to give you all the side lengths. I don't need to tell you all of its angles. All I need to do is provide you with a subset of that information, and then, using the rules of Euclidean geometry, you can infer the missing information. You can determine side lengths and angles that I have not given you. Geometry is magic, but it's also useful. We can use Euclidean geometry to build houses and to construct pyramids, precisely because Euclidean geometry is a good approximation for the world that we live in, at the speeds we're used to traveling at and the distances we're accustomed to. I want to use geometry to solve a problem in particle physics, a problem of missing information. You see, in particle physics, we explore the world around us with the ultimate goal of determining what particles make up our universe. The problem is, the further we go and the more information we uncover, the more difficult and expensive further progress becomes. Recently, we had a huge success with the discovery of a new particle known as the Higgs Boson. But in order to make this discovery, we had to spend $10 billion constructing an experiment the size of a city, using a multinational collaboration which spanned well over a decade. What if we could do better? Imagine if we had a geometry which described particle theories in exactly the same way that Euclidean geometry is appropriate for describing the world around us. Well, then presumably we could use the rules of this new geometry to uncover information about particles that we've not yet discovered. It might even tell us where to look. Now, it just so happens we have such a geometry. It's called non-commutative geometry, and it's the focus of my research. I use the rules of non-commutative geometry together with information about particles that we've already discovered to infer information about particles which our current experiments are not yet powerful enough to detect. And in doing so, I can save us a lot of time, a lot of effort, and a lot of money. Now, we're a curious species, and fundamental research fuels our social and technological development. The ancient Egyptians used geometry to construct the pyramids. Now, with our new geometry, our new understanding, our new magic, let's see just how far we can go.